3.6, we are simplifying expressions involving dividing monomials. So we've been multiplying monomials. Now we're dividing. What's the rule for if we're multiplying? What do we do with the exponents? Add them. So what do you think the rule is going to be when we divide them?
Subtract.
We subtract. So this is what we call dividing powers. Okay, so if I have a to the m divided by a to the n, this is the general rule, I get a to the m minus n. So I just subtract those exponents. This is a shortcut. What we're going to do at first is we're going to expand it all and just start canceling, okay, so that we can see why it works. Let's think about it for a second. We're going to do this in our actual examples, but this is just the general case. Let's say I have x to the 5th divided by x to the 3rd. X to the 5th is the same as x times x times x times x times x. Is everyone okay with that? We're multiplying x 5 times. Divided by x to the 3rd, that's x times x times x, right? Then whenever we have something on top and the same thing on bottom, what do they do? Why do we cross them out though? Because x divided by x, what does that give me? Not 0. Any number divided by itself is 1. So they cancel each other out. So this cancels, these guys cancel, and these guys cancel. So what's left? 2. X squared. What's 5 minus 3? 2. So that's the shortcut. I'm not going to let you do the shortcut at first. Okay, so let's look at example 1. X to the 11th divided by x to the 5th. So we're going to write it all out. X to the 11th is x times itself how many times? X times x times x times x. 11 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're multiplying x 11 times on top. How many times on bottom? 5. So x times x times x. 5 times. 1, 2, 3, 4, 5. Okay. Now I'm going to cancel out my x's. One on top for every one on bottom. So these guys cancel. These guys cancel because we get 1. 1. 1. Yeah. You did it in pre-algebra. So what's left on top? 1, 2, 3, 4, 5, 6. X to the 6. What is 11 minus 5? 6. Very good. So what happens if there's a bigger number on the bottom? Let's try it. Oh my gosh, that's a lot of y's to write out. We're not going to write out all the y's.
Let's put y times 20.
It's not the same as y times 20. Okay. Y to the 20 is the same as y times y times y. I'm going to do dot 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 times y 20 times, right? So I'm going to put 20 times. So we actually have 20 y's up here. The dot 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 just means I didn't want to write them all. Okay, divided by y times y times y times dot 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 times y. How many times on the bottom though? 30 times. Okay. Alright, so I have 20 y's being multiplied on top and 30 y's being multiplied on bottom. How many of them are going to cancel? 20 of them. Then those are all the ones on top, right? So every single one on top is going to cancel with one on bottom. Okay? Cancel, cancel, cancel. So how many y's are left on top?
0.
0. So what do we put as a placeholder? A 1. How many y's are left on bottom? 10. So y to the 10. So my answer is 1 over y to the 10. What is 30 minus 20? 10. But my answer has to stay wherever the bigger exponent is. Does that make sense? Okay. What if I didn't do that? What if I just did y to the 20 minus 30? What's 20 minus 30? Negative 10. So my answer would be y to the negative 10. Is that an acceptable answer? No. What do we have to do? Put it over 1 and he gets kicked out, so he moves downstairs. So this is the same as 1 over y to the 10. So we do get the same answer. What? So another way to remember it, guys, is we have up here y to the 20 divided by y to the 30. So now we're looking at the shortcut. Keely made a good suggestion. She said, well, can't you just take the smaller number, bring it down to wherever the bigger one is, and then subtract? The answer is yes. Okay, if we bring all of the y's down to the bottom, we're still left with a 1 on top, correct? And then what is 30 minus 20? 10. Our answer still needs to be, though, 1 over y to the 10. And I want to bet that at least half of you tomorrow on your homework would have written y to the 10th as your answer. Okay? So let's try something with a little bit more variables to keep track of. So example 3, x squared y to the 5th, x to the 7th, y squared. So this one we're going to write it out so that we can see it, and then we'll start using the shortcut, okay? So let's do the numerator first. I need to put an equal sign. X squared is x times y to the 5th. That's y times y times y times y times y. 1, 2, 3, 4, 5 times. All over, expand the denominator, x to the 7th. X times x times x times x times x. 1, 2, 3, 4, 5, 6, 7 x's times y squared. So times y times y. Okay, now we can only cancel x's with x's and y's with y's. So let's cancel our x's. Let me use a different color. Okay, this x on top cancels with 1 on bottom. This x on top cancels with 1 on bottom. Are there any more x's to cancel?
No.
No, so let's start canceling the y's. These two cancel. These two cancel. Any more to cancel? No, so who is living in the numerator? Y times y times y. That's y to the 3rd power. X times x times x times x times x. That's x to the 5th power. So this would be our answer. So let's try it with the shortcut. Let me rewrite it. X squared.
There's another thing you can do.
Y to the 5th. X to the 7th. Y squared. Okay. I'm going to take care of the x's first. I have x squared on top. X to the 7 on bottom. So where are my x's going to end up? On top or bottom?
Bottom.
On bottom. So on bottom, I know I'm going to have x to the 7 minus 2. Then let's look at our y's. I have y to the 5th on top, y squared on bottom. Are my y's going to end up on top or bottom?
Top.
On top. Why on top?
Because it'll end up negative. Take the lower number.
Well, do I have more y's on top or on bottom? On top, right? At y to the 5th. So that's going to be y to the 5th minus 2. 5 minus 2? Y to the 3rd over x to the 7 minus 2. 5. We get the same answer. Yes. So what you all to do, try example 4 on your own. Try using the shortcut. Okay, so we're going to worry about the A's first. I'm going to do them in different colors. Okay, I have A to the 10th, A to the 32. Am I going to bring 10 down to 32 or 32 up to 10? 10 down to 32, how come?
Because they're bigger.
Because 32 is bigger. So on the bottom, I know I'm going to have A to the 32 minus 10. Okay, and then I also have B's to worry about. On top, I have B to the 8. On bottom, I have B to the 10. Which one am I moving? B to the 8, because B to the 10 is bigger. So B to the 10 minus 8. So who's left on top?
1.
Just a 1. So that's going to give me 1 over A to the 32 minus 10, A to the 22, B to the 2nd. And that's my answer.
How many examples are there?
I just told you 2 more. Okay, what happens if there's a number involved? So for this example, I have 9x to the 15th over 18x squared.
8.
Okay.
This is 8.
18x to the 8th. Oh my gosh, I totally read it wrong. Okay? We're going to follow the same steps as when we were multiplying. Signs, numbers, variables. So let's do signs first. Positive divided by a positive. Positive. Okay. What about 9 divided by 18? What happens there? Don't tell me the answer is 2.
It turns into a fraction.
It turns into a fraction. 9 goes into 9 how many times? Once. 9 goes into 18? Twice. So what's living on top? A 1. What's living on bottom?
2.
A 2. Okay, now let's do the variables. X to the 15th over x to the 8th. Or my x is going to end up on top or on bottom? How come on top? Because x to the 15th is bigger. Okay, x to the 15th is bigger, so we have x, 1/15. X to the 15th minus 8. That gives me x to the 7th. Do I have to write the 1?
No.
Over 2. What do they want?
Brandon needs to go to student first.
Okay.
Which one, you or me?
You.
He talks to him about himself in the third person. Last one, example 6. I want you to try it on your own. 6x to the 7th divided by 6y to the 7th divided by 8xy to the 12th. 6y to the 7th divided by 8y to the 12th. Alright, signs. First thing we're looking at is signs. We have a positive divided by a positive. What does that give me? Positive. Then we do our numbers. We have 6 over 8. Does that reduce at all? Julia says yes. Julia, what goes into both 6 and 8? 2. 2 goes into 6 how many times? 3. 2 goes into 8? 4. So we have a 3 on top and a 4 on bottom. So we need to reduce our coefficients as much as possible. Okay, y to the 7th over y to the 12th, variables. Okay, which one is moving, the 7 or the 12? The 7 because it's smaller, so we're going to end up with y's on bottom. 12 minus 7. So on top we have 3, on bottom we have 4y to the 5th.
Can we check homework now? No.